By the mid-1970s, the MiG-25 had achieved credible worldwide recognition. It had become a source of some concern to potential enemies of the Soviet Union. Foxbat was the code name NATO gave to the MiG-25 interceptor. Foreign intelligence agencies were desperate for anything they could get on this new Soviet aircraft. Any information was gratefully received. The Cold War was actually a hotbed of espionage activities and minor political and military incidents. One famous episode during East-West confrontation happened in 1976. The MiG-25 found itself the focus of worldwide attention. 6th of September 1976, Senior Lieutenant Viktor Bilyenko hijacked the top-secret fighter to Japan. He flew the MiG-25 from the Russian Far East aerodrome at Chuguyevka to Hakodate Civil Airport in Japan. Along with the aircraft, the Japanese got access to the top-secret Soviet IFF codes, that's identification friend or foe, and other Soviet military secrets. The MiG-25 design included a high wing, that's to say at the top of the fuselage, swept back by 42 degrees. There were two big tail fins and two ventral fins to improve the longitudinal stability at high speeds. The specifications included a service ceiling well over 20,000 meters and a maximum speed of 3,000 kilometers an hour. And that was what decided the general layout of the aircraft. The fact is that when you're near 3 times the speed of sound, the aircraft's structure gets extremely hot. Some parts can reach a temperature of 300 degrees Celsius. At those sorts of temperatures, traditional aluminium alloys lose their strength, so you have to use steel or titanium. Indeed, the American SR-71 was mainly made of titanium. The MiG-25 structure is mostly high-tensile stainless steel. We decided to use heat-resistant stainless steel. We very quickly mastered the technology and completed the manufacturing process of the fuselage and the other bits of the structure. It wasn't long before we could start actual production. Tests showed that the whole structure could withstand the kinetic heating of high speeds. Some of the structural materials were unfamiliar to the Soviet aircraft industry. They needed radical changes to the technology. With aluminium, the main way of fixing components and skin is with rivets. But for high-tensile steel, you need welding. At the Electric Welding Institute, academician Boris Patonov was developing unique methods for spot and arc welding. They provided the strength and structural integrity that was needed. This was distinctive technology, unique to the Soviet Union. The fuselage was welded automatically in an assembly frame. As the frame rotated with the fuselage, automated welding guns were working on it. We'd found we couldn't just set up the fuselage and start argon welding, so we fixed it inside the rotating frame. And when the argon welding was finished, all we had to do was take the fuselage out. The fuselage was an all-welded structure. It was, in fact, a huge fuel tank. Next, the outer wings, the tail units, and some other bits were attached to the aircraft fuselage. Special insulating panels had to be fitted to protect the area around the engines from overheating. The panels were silver-coated. 5 kilograms of silver were used in their manufacture. Because of the high temperatures involved, new rubber and other sealing materials had to be specially created. And the canopy also had to be heat-resistant. Special fuel was required. Unlike regular jet fuel, it was heat-resistant and it could retain its properties at high temperatures. Obviously, both crew and equipment needed to operate in comfortable conditions. So efficient air conditioning and cooling systems were fitted. The R-15B-300 engines were developed in Sergei Tumanskaya's design bureau. They each developed 11,200 kilograms of static thrust in reheat. The R-15 was designed to give maximum performance at high altitude where the air is thin. At the time, it was unique, the only high-altitude engine made in the Soviet Union. To optimize its performance, it had an electronic fuel supply system and a 3-position nozzle. The engine air intakes had movable wedges which automatically regulated the airflow according to flight conditions. The global standoff between the USSR and the USA forced the politicians of both countries into quick decisions with quick results. The revolutionary MiG-25 was designed and built in just 3 years. When I was the assembly hall manager, Mikoyan himself, Mikoyan-Gurevich, would say, "Well, why don't you fix the problem? We want you to sort it as soon as possible. This is not good, Comrade Stepanov. Don't you understand? This job is more important than anything else." The chief designers, in fact the whole Mikoyan Design Bureau, were technically very knowledgeable. They knew just what should be done and how. They knew which specialist to use to get the best results. They knew how to do tests. Artem Mikoyan set out to build cooperation with the best aircraft makers in the Soviet Union. And he succeeded. In particular, he set up good links with the Dubna engineering plant, and they went on to produce parts for the first prototypes and also for the production MiG-25s. December 1963, the first prototype is delivered to Zhukovsky Aerodrome. This is a reconnaissance version of the fighter, designated E.L.D. 6th of March 1964, Mikoyan Design Bureau test pilot Alexander Fedotov makes the maiden flight of the E.L.D. I remember that day very well. We had a potential accident during that maiden flight. It was quite cold, about -12 degrees Celsius. Earlier, we'd installed sensors on the aircraft to test the flight systems in flight. We had a remote health checking system in the sensors, and soon after takeoff, I got a warning indication that the fuel pumps weren't working. Afterwards, it appeared that an important fuel agent hadn't been added to the aircraft tanks. It was a sort of antifreeze for kerosene. As you know, kerosene contains water, and during the flight, the water froze in the pumps. Luckily, Fedotov managed to turn back to the aerodrome and land. He was very lucky to have had enough available fuel to get back. If the flight had been longer, the engines would have been shut down. 9th of September 1964, the Ye-155P1 makes its maiden flight. It's the Interceptor prototype, flown by test pilot Pyotr Ostapenko. You always treat a first flight like a newborn baby. I took off carefully, maneuvered the new baby round a bit, tried the engines at different settings and checked some of the new aircraft systems. I was doing it all very carefully and at subsonic speed, of course. I didn't go above 5,000 meters high. And then I slowly and carefully started my descent, came back to the aerodrome and landed. There were no serious problems in those early test stages. It is always the case with a new aeroplane that you get some minor problems, but they were solved. For example, the tests revealed a lack of directional stability at high speed. First, they tried putting an early version of the modern winglets on the wingtips. They called them flippers, but that didn't seem to help. So instead, they enlarged the tail fins. The high temperature generated in flight was another problem. It wasn't the aircraft's structure that was suffering, but the skin. After a few flights at high speed, the Soviet red stars had almost disappeared. Horrors. Nobody thought much about the red paint, but obviously we had to have red stars on the plane. After several flights, you could see the stars starting to peel off the aeroplane's skin. So next we had to develop a new heat-resistant paint. Within a couple of weeks, we'd got our new paint, and it worked. Everything was going well. Gradually, MiG-25 performance was improving. Full-scale production was arranged to be at the Gorky aircraft plant. Operational testing of the new aircraft started in 1965. There were up to 11 aircraft at a time on test at Akhtubinsk, each with its own mission. There were something like 700 different specialists from different organizations. We worked as long as necessary to get to where we wanted. If the weather was good, we worked weekends. Everybody was enthusiastic. They had this feeling that this aeroplane would be a real winner. Thing is, the MiG-25 was different to anything that had gone before. With its impressive size and its strange shape, it was picking up some odd nicknames. I was working as a flying instructor. I'd never seen the MiG-25 before. But then I became a test pilot. I was looking out of the office window one day and I saw this very unusual aircraft taxiing past. I thought, what's that? The shape was so weird. I figured that any fighter with pretensions to really high speed would look more like a rocket. But this thing didn't look like a rocket at all. And to my eyes, it didn't have the right shape to achieve good aerodynamic performance. So I said to a colleague standing next to me, "What's that?" He said, "That's a Phantom." I didn't get the joke. I thought he was serious. But huge air intakes, wide fuselage, 2 tail fins, 2 great big jet nozzles, everything looked quite wrong to me. In July 1967, it was decided that the MiG-25 should take part in an official flypast at Domodedovo, even though operational testing hadn't been finished, as part of the 50th anniversary celebrations of the October Revolution. A loose formation of MiG-25s flew over the aerodrome in front of the distinguished guests. The new shape in the sky caused a sensation. One of those aeroplanes was flown by military test pilot Yegor Lishnikov. 3.5 months later, on the 30th of October, Yegor Lishnikov set out to break a time-to-height record with the MiG-25. After takeoff, he accelerated the aircraft in reheat and started a high-speed climb. He quickly exceeded the speed limitation. At altitude 1,000 meters, the aircraft started banking to the left. Lishnikov tried to correct the uncommanded bank with a right movement of the control column, but he was going too fast, and the result was what's called aileron reversal. Lishnikov's stick movement to the right caused an even bigger bank to the left. The airplane began a steepening dive. Yegor Lishnikov managed to eject, but because of his high vertical speed and low altitude, he had no chance. He didn't survive. The lack of effectiveness of the flying controls remained a problem during missile testing as well. After a missile launch from an outer wing hardpoint, the aircraft would sometimes roll on its back and dive steeply. Military test pilot Nureyev Kazarian was the first one to experience this. Immediately after a missile launch, the aircraft zoomed and started rolling over. I pushed the control column the opposite way and tried to recover the aircraft, but it didn't respond. It continued rolling and began to dive almost vertically. I still had no control. The aircraft was diving very fast. Only at an altitude of 12,000 meters did it start very gradually responding to the controls. At 10,000 meters, I finally got it under control and started leveling out. Eventually, I got it level and turned towards the aerodrome. A missile launch had never caused such an upset before. It was a big problem, and it had to be solved. Big changes had to be made to the aircraft control system. In addition to ailerons on the wings, tailerons were fitted on the tail, and that greatly improved the roll control. When missiles were launched, the tailerons engaged automatically and stopped the aircraft rolling. There was another tragic accident to the MiG-25 in 1969. On the 28th of April, the Air Defense Aircraft Commander-in-Chief, Lieutenant General Anatoly Karamtsov, was killed during a familiarization flight. The cause was an engine fire. Artem Mikoyan himself became personally involved in the crash investigation. As chief designer, he was very upset about the tragedy. A month after Karamtsov's death, Mikoyan had a heart attack. He never recovered. The great Artem Mikoyan died on the 9th of December 1970. Operational testing on the reconnaissance aircraft and the interceptor was completed in 1969 and 1970, respectively. The interceptor was designated MiG-25P and the reconnaissance aircraft MiG-25R. They became operational in combat units in the early 70s. Single-seat MiG-25P interceptor. Length 19.75 meters. Height 6.5 meters. Wingspan 14 meters. Maximum takeoff weight 36,720 kilograms. Maximum flight speed 3,000 kilometers an hour. Service ceiling 20,700 meters. Range 1,730 kilometers. The reconnaissance version had increased range and a higher ceiling. There was a twin-seat version of the aeroplane for pilot training. Both the reconnaissance aircraft and the interceptor had their own twin-seat versions. The instructor sat in the front cockpit, the trainee behind. Pilots mastered the MiG-25 very quickly. Most Soviet military pilots yearned to fly this airplane. After all, it was the fastest and highest in the Soviet Union. When you select reheat for takeoff and you feel the fierce acceleration, the MiG-25 seems to come alive. The faster it flies, the easier it is to control. You go faster and faster, and then at some stage, you suddenly feel on top of the world. It's a great feeling. I can't even begin to describe it. I only ever had that feeling when I flew the MiG-25. The MiG-25 was designed to fly very high, 20,000 meters, say. The upper atmosphere was its real home. It wasn't much good at low level. No, the top of the atmosphere was where the MiG-25 felt great. Military pilots were not allowed to exceed 3,000 kilometers an hour on the MiG-25. That's roughly Mach 2.83. But during test flights, they achieved speeds higher than that. General designer Artem Mikoyan signed a special order and it became an official document. In it, he ordered me to make 6 flights and achieve Mach 3. That's 3,200 kilometers an hour. As well as the MiG-25's extraordinary performance figures, there was another thing that endeared it to pilots and technicians alike. The air conditioning system used a mixture of water and alcohol. It took 240 liters of this unlikely liquid. At supersonic speeds, the alcohol would evaporate and cool various components. 240 liters of pure alcohol mixed with distilled water is a lot, and that's why the MiG-25 was jokingly referred to as the booze carrier. After flight, some of the remaining liquid would miraculously disappear. People call it Massandre. It was a Crimean wine. Artem Mikoyan was a wine lover, and he thought it was a great joke. Quite unexpectedly, bad news started coming in from Air Force regiments. They reported sudden loss of aircraft control at low altitudes and at speeds greater than 1,000 kilometers an hour. In 1973, MiG-25s were being lost one by one. Pilots too. But nobody knew why it was happening. First one accident and then another. And then one day, a pilot managed to save his aircraft. It was delivered to the Flight Research Institute at Zhukovsky. We tested it for a long time, but we still couldn't find any reason for the failures. Everything seemed to be working fine. The Zhukovsky Flight Research Institute was pouring resources into the problem, including test pilots Leonid Rybakov and Oleg Gutkov. They tried to replicate the regiment pilot's loss of control, but it wasn't easy. The aeroplane behaved quite normally. 4th of October 1973, Oleg Gutkov is scheduled to make the final flight in the test series. The plan is to do 8 high-speed flypasts at different altitudes, stirring the control column a little. He does that, but everything stays within expected limits. Before he lands, Gutkov decides to do another high-speed flypast. Altitude 1,500 meters, speed 1,100 kilometers an hour. Suddenly there he is. The MiG starts rolling wildly. Calmly, Gutkov calls on the radio, "It's rolling, it's rolling." Those were his last words. The aeroplane crashed in the town of Bremenskaya in the Moscow region. The only fatality was Gutkov. The aircraft hit the ground so hard, the engine broke in pieces. Oleg Gutkov paid with his life to find the reason for these failures. His loss of control took place at a critical moment within a narrow range of speed and altitude. That is, at a certain airflow pressure. It had been really difficult to find what the problem was. You just didn't know where to start troubleshooting. Well, at least we hadn't known until Gutkov's death. When the anomaly had started happening, Gutkov had said over the radio that his aircraft had started to roll and he wasn't able to control it. That roll was the key to solving the problem. We realized there was something wrong with the tail unit. This was what it was. We talked earlier about the MiG-25 having tailerons. The sections of the tailerons on either side could move in opposite directions. But at a particular speed and altitude, if the pilot slightly stirred the control column, one of the taileron sections would jam. The hydraulic actuator wasn't able to return the section back to its proper position. Suddenly, the pilot couldn't move the control column. The airplane would start an uncontrollable roll at low altitude, often with fatal results. The answer was simple. Move the taileron axis forward by 14 centimeters. The regiments that flew the MiG-25 interceptors were structurally a part of air defense aircraft. That in turn was part of the air defense system of the country. Parked on their special stands, aircraft were on standby day and night. The standby pilots ran to their cockpits and took off for their interception. The interception line was 600 kilometers. The interceptors were guided to their targets by ground-based radars. The operator would enter the target and the interceptors into a targeting channel. The equipment would then track the enemy and transfer the targeting data to the aircraft. There were 2 options. In one, instrument panel indicators would show the pilot the direction to the target. That was called direct targeting. And in the second, everything was automatic. Pilots didn't have to do anything. At a certain range from the target, the interceptor's radar would take over the targeting. Air target detected, closing range. The MiG-25P had the Smirch A radar system that had been developed by a design team led by Fyodor Volkov. The radar could detect a target 100 kilometers away. At 60 kilometers, the target would be locked on and the radar would start auto-tracking. The MiG-25P could carry 4 R-40 missiles. In fact, they were the interceptor's only weapon system. The R-40 had been designed by Matusa Biznovat. The R-40 was actually quite big and heavy, at 6 meters long and weighing in at 470 kilograms. There were 2 versions, one with a heat-seeking head and the other with a radar homing head. The launch range of the R-40 was 30 kilometers. The MiG-25P could hit a target flying at any altitude between 500 and 27,000 meters and at a speed as high as 3,200 kilometers an hour. The attack in the front hemisphere, that's to say head-on, was a particular challenge. The interceptor's closing speed on the target could be as much as 1.5 kilometers a second. The pilot had just a few brief moments for firing. When I was approaching the point where I would need to launch a missile, I would operate the launch trigger some way in advance. And then, after the aircraft radar had locked onto the target, the missiles would be launched automatically. It became clear after a while that the capability of the MiG-25P had a significant impact on US military plans. High and fast direct penetration by American aircraft had become impractical. The Valkyrie strategic bomber progressed no further than experimental status, and the SR-71 reconnaissance aeroplane found itself with serious opposition. The SR-71 was absolutely not an aircraft for large number production, either in technological terms or in the numbers required for operations. In fact, there were only ever about 30 of them, and the pilots were required to be of test pilot status. The crew were kitted out like astronauts. It took about 24 hours to prepare the aeroplane for flight. By contrast, the MiG-25 was always on alert, ready to take off for combat within 2 minutes, flown by regular military pilots. About 1,000 MiG-25 aircraft were produced. Let's take a look at the reconnaissance version now. The MiG-25R was delivered to frontal aviation units of the Air Force. But this reconnaissance version was not to be around for long. In 1969, word came from the top that the R version was to be modified to become a reconnaissance bomber. The MiG-25RB could carry up to 10 500-kilogram bombs. The bomb aiming and navigation system was called Peleng. Most of the time I flew the RB version of the MiG-25. We used that for testing the Peleng bomb aiming and navigation system. I'd enter the coordinates of the target into the system, and the aircraft would navigate itself to the bomb release point. It was completely automatic. I didn't have to do anything, except, of course, monitor the whole thing. Well, actually, I did have one task. The system would give me the command, attention, release, and I would push the bomb release button. That way, the pilot would be making the final decision as to whether to drop the bomb or not. Normal bombing mode, altitude 20,000 meters, speed 2,500 kilometers an hour. At our cruising speed of Mach 2.3, we'd drop our bombs at 42 kilometers range from the target. Although the bombs would slow down as they fell, they'd still be supersonic at the moment of impact, and they would sometimes penetrate the ground to a depth of 30 to 40 meters. In the reconnaissance role, there were three main versions of the aeroplane: photographic reconnaissance, electronic reconnaissance, and radar surveillance. The military conflicts in the Middle East provided real combat experience for the MiG-25RB. In the spring of 1971, 5 aircraft and crews left the Soviet Union for Egypt. There was to be no bombing, but reconnaissance missions were carried out to perfection. It was a highly effective detachment. The Egyptian headquarters staff showed us the maps that supported their plan for dealing with the military situation around the Suez Canal. But after our flights, it was clear that the maps were wrong. The MiG-25RB flew over occupied Sinai and over Israel. Sorties were flown at more than 20,000 meters altitude and speeds up to 3,000 kilometers an hour. The aircraft equipment produced high-quality images with the finest definition. I was surprised by the detail. The altitude was more than 20,000 meters, and on the Fayum lake shore I could see boats, and I could see the oars in some of them. The oars were not lying in the boat, but being used on the water. It was all clearly visible. Israeli fighters repeatedly took off to intercept the MiG-25RBs, but they didn't get close. The Hawk surface-to-air missile system couldn't hit them either. The third or fourth flight was along the Suez Canal. It was over Egyptian territory, but still close to the canal and to the Israeli occupying forces. Our systems detected that at that moment there were 48 fighters airborne and out to intercept my plane. But they couldn't make it any higher than 15 to 15,500 meters. We were at more than 20,000 meters. The arrival of the MiG-25 reconnaissance aircraft opened a whole new era in Soviet reconnaissance. The aircraft could cover huge areas. It offered pinpoint accuracy in defining the coordinates of targets, and it could then transmit that data in real time. And all this was happening so high and so fast that no other aircraft could stop it. The history of the MiG-25 is illuminated by bright splashes of world achievements. At various times, MiG-25s have set about 40 world records. Some of them remained unbroken for many years. A MiG-25M still holds the absolute altitude record for a jet aircraft, 37,650 meters. That was set by Alexander Fedotov on the 31st of August 1977. With the creation of the MiG-25, the Soviet Union became strong as a great aviation power, and the Mikoyan Design Bureau gained invaluable experience in designing high-speed, high-altitude aircraft. In the 1970s, the MiG-25 successfully fulfilled everything it was asked to do. But then, more complex missions started appearing. The Mikoyan Design Bureau, along with the developers of avionics equipment, armament and engines, were called on to climb new summits.